So in the repo online, I've put up an R Markdown document that I'm basically using for this, and I've put up one data set. So I'm using one data set that's not available through an R package as you would normally have. So let me start, get the screen share going here. Make sure the screen is, everybody can see. Okay, so I think you should be able to see my screen now. And I'm going to kind of just flip between the R Markdown document and R itself, which I'm just running locally myself. So the topic of this training is data visualization with base R and ggplot2. And for data exploration and for the projects we're doing under data science for the public good, I think you can maybe make an argument that data visualization is probably one of the most important topics. Because at the end of this, we're going to have some posters, and to communicate our projects to stakeholders, we want to have appealing visuals. So the goal of this module is to briefly introduce how to visualize data in base R, and that's fairly brief because for most of the visualization, we're going to use ggplot2, which is a package for plotting. ggplot2 was created by Hadley Wickham. So I know in some of the other trainings we've talked about the tidyverse. ggplot2, I believe, is part of the tidyverse. So I think if you call tidyverse, it will call ggplot2 package. And as Aaron said, I think in a training a couple of days ago, what you'll find is that ggplot2, once you understand the language of ggplot2, it's very easy to create appealing graphics or visualizations. And that's largely because ggplot2 has really nice default settings for most things. But like most of the tidyverse packages, there is a little bit of a trade-off in the sense that ggplot2 is very verbose in some sense. And if your data doesn't look like what ggplot2 expects, then you can have some problems. And so we'll see that. So I first wanted to just talk about data visualization in general. Let's see if I can, no, I can't see the chat. So in general, so maybe if I could see, or somebody could tell me in what people put in the chat. I wanted to ask a question, which is, so many of you are in statistics and data analysis programs, and I'm sure you've talked about visualization. So what is kind of the #1 data visualization you've ever heard of? So like, what's the best graphic or visual you've ever seen?
Like a histogram or a bar chart, maybe, or a scatter plot, something like that.
Yep. There's a specific one I'm thinking of, though, that comes up a lot in kind of introductory courses.
Maybe Tableau. Tableau.
Yeah. Well, the Tableau is a software.
I think the like Napoleon march through Russia.
Exactly. Yes. So I have that here. So you should be able to see it now. So obviously this was created before we had computers. I think this is drawn by hand, but this is widely considered one of the best data visualizations because it essentially plots 6 different variables, and I may not be able to remember what they are, on one graph. And what this is plotting is Napoleon's campaign in Russia, 1812 to 1813. And you can see on the left, we're starting, I guess, somewhere to the west of Moscow. And what you're visualizing is Napoleon's grand army marching to Moscow, being defeated, and then retreating away from Moscow. So the what is that, tan line is the grand army going to Moscow. The black line is the retreat. And what's very interesting about this graphic is the width of this line is the size of the grand army. So the number of men. And down here in the bottom, you have the temperature over the retreat. And unfortunately, the temperature is given in, I don't speak French, Réaumur units. I don't know what that is, but I did read somewhere that this translates to like minus 35 Celsius. So very cold. And once you understand that about the plot, you can essentially see the main information that we're supposed to get, which is that, right, this campaign started with a ton of men. And by the time the retreat was complete and you get back down to here, well, almost everybody died, basically, is what you can see. So it's a little morbid. There are numbers that can, that indicate the size of the army. I think this is like 422,000 people. And by the time they were back, that's maybe 20,000, I guess. So that's widely considered the best data visualization because just so much information is presented in one chart. It's very easy to read and understand. A little easier if you speak French and you can actually read the labels, but even for non-francophones like myself, still possible just to see what's going on there. So our goal in this training is to mimic this plot, certainly not in complexity, but we do want visualizations that are easy to read and correctly display the information that we want to convey to stakeholders. So I'm just going to go through the R Markdown document, and I may do some things in R. So the first thing you would want to do is load the tidyverse package and load read Excel package, because the data set that I put online is an Excel file. And we're going to use three data sets actually today. The first is the throughput data set, which is what is in the GitHub repository. And what this contains is something that's very COVID-19 relevant. It contains daily measurements on passengers passing through TSA checkpoints for 2020 and 2019. We're also going to use an air quality data set, which has air quality measurements by day for New York City for certain months in the summer of, I believe, 1972. And then we're also going to use a diamonds data set. So if you have the Excel file downloaded locally, you of course will have to change the path here, but you can make this call to read Excel to read that in, and then I name the columns date, passengers 2020 and passengers 2019. And the air quality data set, I think is in one of the tidyverse packages. So if you've loaded tidyverse, you can just assign that air quality data set. I'm going to call it air. for instance. So visualization in base R. In base R, most visualizations or types of plots have standalone functions. So there's, for instance, there's a specific function for plotting scatter plots. There's a specific function for making histograms. That's a little bit different than ggplot2. So one thing that we might be interested in, just to get us started, very simple, scatter plot. We can use the plot function to plot the number of passengers in 2019 versus the number of passengers in 2020 for the same day. And that's what I've done here. You can see that you make the call to plot. The X variable is going to be passengers in 2019. The Y variable is passengers in 2020. And this is what we get. So let me really quickly at least run this code in R in case I need to come back to it. This is what I want. And you can see that this plot is maybe somewhat informative. It doesn't look very nice in the sense that we have axis labels that are taken from the names of the variables in the data frame. The axes limits are not the same. And these are things that we might want to correct because those make the plot much more readable. In fact, one of the kind of common mistakes, and if you go on the internet and you just search for like bad plots or misleading plots, a lot of the times those misleading plots are misleading but because the scaling on the axes are wrong, or they're manipulated to give a certain impression of the data that's not necessarily what the data is telling you or what's true. So if you go just search for kind of misleading plots, you'll find that a lot of times it has to do with the scale of the axes. So within the context of this plot function, and you remember that in R you can bring up, if I do question mark plot, that would bring up the help page, and you can click the default scatter plot function. That's where we would find information about all these different arguments to the plot function. We can adjust the X label with this XLab argument, the Y label with the YLab argument, and we can set the limits of the X and Y axes. And if we do that, we get a plot that looks a little bit better. It still could be better, but we can see that we have a lot of low values in 2020, which is, of course, when we get the coronavirus, and so that kind of makes sense with what we would expect in the data. So scatter plots, we will use the plot function. If we want a histogram, the scatter plot is very nice for visualizing. A scatter plot or line plot, of course, is nice for visualizing relationships between two variables. Sometimes we care about the distribution of a single variable, and that's where we might want to use a histogram, for instance. So we could be interested in the distribution of passengers per day. In R, the base function for histograms is this hist function. So if we want to see distribution of passengers per day in 2019, we would just call hist on the number of passengers in 2019. And this is what we get. This is kind of what we expect. So basically, we should be around, that's How many threes is that? That's a million. 2 million to 2.6 million passengers per day in general. Another way of visualizing the distribution is to create a kernel density estimate. And that's similar to a histogram, but it gives us basically a smooth distribution. So it's or a continuous distribution. So it's like a histogram, but it's smooth. And even if you don't know anything about how you construct a kernel density estimate, basically what it is every time there's an observation, they put a normal distribution on top of that, right? And then they scale it. Now, base R does not have a function for plotting kernel density estimates that I'm aware of. So what you have to do in base R is you have to first compute the density estimate and then you plot it. And so that's what you see here. We call density on the number of passengers in 2019 and assign that to this object that I'm going to call smoothed, and then tell R to plot that smoothed object. And of course, that smoothed object is a density object. So when you ask R to plot it, it knows what to do. And you can see that it's very similar to our histogram we had, except it's been smoothed. So that's one difference we'll see when we get into ggplot is, unlike base R, where we have to make a call to the density function and then plot that object, in ggplot, you can just innately, you don't have to compute the density first. ggplot's going to compute the density behind the scenes. Another type of graphic that we want to discuss is box plots. Another way of visualizing a distribution of variables. So you can think of, right, a histogram is a way of visualizing a distribution of a variable. A kernel density estimate is another way of visualizing a distribution of a variable. And a box plot is yet another way of visualizing a distribution of a variable. So I'm going to go, for this example, to a New York City air quality data set. This data set contains measurements on ozone, solar radiation, and other weather variables by month and day for New York City between May and September of 1973. We're going to use the box plot function to plot maximum daily temperature by month. So we want the distribution of maximum daily temperature, but we're going to plot that by month. One thing with this air quality data set is that month is not a factor. So when you went through the introductory R training, you probably learned that with categorical variables, R wants to treat them as factors, and they can be unordered or not. So the first thing we need to do is convert this month variable to a factor, give it labels of May, June, July, August, and September. So if you looked at air quality data set, which I called air, you'll see that right now, month is just denoted by a number. But we want to actually, when we plot this thing, we want to use character labels. I guess you could plot 5, 6, 7, 8, 9 here, but it's much nicer to have the month names. And so that's why we first convert to a factor. Keep wanting to open that. So once we've done that, we can create the box plot using the box plot function. We assign a nice descriptive label for the x-axis, a nice descriptive label for the y-axis, and it's as simple as that. Another type of common plot is a bar chart. A bar chart, of course, is just a chart where the length of the bar is proportional to the value of the variable. In R, that's accomplished with the bar plot function in base R. So for instance, we might be interested in cumulative radiation in each month. So we will have, the month, and then we'll have a single value for the sum of the radiation in that month. So this code first sums the radiation in each month with aggregate, create names for the month and the summed amount of radiation, and then the bar plot is fairly simple at that point. So the height of the plot, we're passing the summed radiation to that. The names argument is the month. And so you get a plot like this. So very easy to do. And apparently July had the most solar radiation in that year. So those are 3 types of basic plots in R. Essentially, if you don't know how to use one of these, you would just go into R, and in the console, you bring up the help documentation for that function. So we have bar plots, box plots, scatter plots, and histograms, essentially. Now, I went through those rather quickly because if you become familiar with ggplot2, you probably will stop using the base plotting functions in R. Because the defaults in ggplot2 are just so much better. So ggplot2, as I said, is a package that if you use the tidyverse, it's automatically loaded when you load the tidyverse packages. And ggplot2 implements what's been called a grammar of graphics. And so what you'll find is that calls to ggplot2, no matter what type of graph you're trying to make, so no matter whether you're creating a histogram or a box plot, a scatter plot, the calls to ggplot2 all look basically the same. So they have this similar grammar. And I'm going to talk about that. I put the links to the data camp courses in here. There are 3 data camp courses that correspond to ggplot2. You should go through those because, of course, doing the coding is probably much more informative than listening to me tell you about the coding. So I'm going to start with a very simple graphic, which is kind of interesting, especially if you're thinking of getting into the stock market or you're following what's been going on in the stock market. One indicator of things that I might want to look at, especially if I was interested in airline stocks, would be what is going on with passenger numbers. And that's very difficult to find out because the airlines, I don't think, publish these numbers, but TSA does publish the total throughput. So total number of passengers going through TSA checkpoints. And that's what I've plotted here in this first plot. So this is using that TSA data set. Remember that TSA data set has 3 variables. It has a date, giving the day. It has the number of passengers on that day in 2020 and the number of passengers on that day in 2019. And the first thing I want to look at is just the line plot for number of passengers in 2020. And that's what I have here. You can see that there are two parts of this call to ggplot2. So first, there's this ggplot function, which basically tells ggplot to get ready. You're getting ready to have to plot something. And then there's this geom line function. And that is a primitive plot. I'm going to talk more about this, but or a plotting primitive. So you can see that what we're doing is in this first call to ggplot, we're telling it what data set to look at. It needs to look at the TSA data set. And in geom line, we are saying, okay, I want to map date to the X aesthetic for this geom and passengers to the Y aesthetic for this geom. Now the geom line is basically saying we want a line plot. So the type of geom you give it is essentially the type of plot that you want. And we can see in this plot that there's a nice big decline in ridership numbers. In about middle 1st of March was when we first really saw this decline happening. And since about the middle of April, we've started to see a slight increase in passenger numbers, and they're continuing to rise. Now, this is a fine plot. You can see that ggplot has some nice defaults. You know, it puts in this kind of gridded area behind things for us. But we could probably improve this, and we could look at some more interesting questions. So one thing you might be interested in is, well, okay, obviously we see a big decline. What does this look like compared to the previous year? So we want to answer this question, we want a line plot, and we want a plot of passengers in 2019 and passengers in 2020. So the first thing I'm going to do is show you the bad way to do this. It works, but it's really not what you're supposed to do. And I actually find myself trying to do this a lot just because often my data is not in the form that ggplot wants, but this is not the way you're supposed to do things. So I can create that plot showing passengers in both years using this code right here. So let's look at this carefully. The ggplot part, that's the same, right? I'm telling it to look in the TSA data set. And here I have two geom arguments. Now, the geoms are basically layers to the plot. So every time you add a geom, you're adding a layer to the plot. And you can see that we've got two layers here. We've got the first line geom, which is the layer for passengers in 2019. And we have the second geom, which is the passengers in 2020. And I've told it to label this first geom, or color this first geom blue, color the second geom red. And we get exactly what we wanted. You know, we get a plot that has passenger numbers in both years, different colors for the lines. But what you will quickly see is that if you were coming at this plot with no knowledge of what was trying to be displayed here, you would be incredibly confused. So you'd be confused first because The y-axis has scientific notation. I think the layperson probably does not like scientific notation, so we would want to change that to just regular numbers. The y-axis says passengers in 2019, which is wrong because we know that the red line is actually showing us passengers in 2020, not passengers in 2019. Moreover, unless we saw the call to ggplot up here, we would have no idea what these two lines are, what the difference is between these two lines. So if you think about the improvements that we can make to this plot, we would want to change the scale of the axis. We want to clean up the axis labels. And it would be nice to have a legend that tells us, you know, the blue line is 2019, the red line is 2020. And to do that, we need to get the data in a form that ggplot likes. Which is what I've done here. So ggplot, it always wants a tibble or a data frame. And what it wants variables that are mapped to aesthetics, okay? So what do I mean by that? If you look here, this AES, those are aesthetics. So you see we have an X aesthetic for this line plot. We're mapping date to the X aesthetic. We're mapping passengers to the Y aesthetic. And what we really want is a color aesthetic. We want the year to be mapped to the color aesthetic. So what we need is a long form data set, right? What we have now is a wide form data set. So what I mean by that is we have every observation corresponding to a date and giving the number of passengers in 2020 and the number of passengers in 2019. For the correct call to ggplot, we want to have a date variable. We want to have a passengers variable, and then we want to have a year variable. Now, what we need to do is basically pivot the table. So there are a number of ways to do this in the tidyverse, and this is kind of one of the problems with the tidyverse is that, as far as I'm aware, there's at least 3 functions that handle table pivoting. The one I'm going to use here is called pivot longer. You would need to look at the help documentation to see exactly how this is working, but basically what it's doing is it's telling us the function not to mess with date. We want to have a date. We want to take year and send that to names and the passengers to value. It's kind of complicated. We could probably have a training just on pivoting tables. But I'm going to show you just what it does, and you'll be able to understand, I think. So this is the first table we had, and this is the new pivoted table. And so you can see that the basic difference is in the first table we had an observation for each day. In the second table, we have 2 observations for each day. So for May 18th, we have one observation that's giving the 2020 value and one observation that's giving the 2019 value. So now the data is in a long format. And when you call ggplot with this new data set, it looks very similar to the previous and incorrect call. We still, since I just renamed the data set, we're still asking it to look at the TSA data set, but we only need one geom here. And we map date to the X variable. We map number of passengers to the Y variable. And we map the year variable to the color aesthetic here. And when you do that, ggplot will automatically create a nice label for you. So you can see that this is in some sense, vastly improved plot, because even if you had no knowledge of what the call to ggplot looked like, you could just come to this plot. As long as you can read scientific notation, you can tell that the red line is the number of passengers in 2019. The turquoise or kind of green line is the number of passengers in 2020. So very easy to tell what's going on here. And this is one of the key points, is that each of these arguments to the aesthetic part of the geom function, each of those arguments are variables, right? So this new data set had a date variable, it had a passengers variable, and a year variable. So ggplot really expects anything that you are putting in this aesthetic part of the geom needs to be a variable in the tibble or data frame that you're sending to ggplot. So this is where ggplot differs from base R, in that base R, if you want a scatter plot, you can send individual vectors to the X value and the Y value. They don't necessarily need to be in a data frame, as far as I'm aware. In ggplot, everything basically needs to be in a tibble or a data frame. Now, changing the labels and other things like this in ggplot is very easy to do. We've improved this plot, but the labels are still, you know, if you're a stickler like me, the fact that these things aren't capitalized might annoy you, and the scientific notation might annoy you as well. And those are very easy to change. So ggplot, basically we're just going to add things onto this call to ggplot. So we have the basic ggplot function where we tell it the data set. We have the basic geom where we're telling it this is, you know, a line plot. And we're going to add this labs argument. So we have labs, the color label, I want it to be year. So and I want it to be capitalized year. So you can see that I get what I want here in the legend. I want the X label to be date with a capital D. I want the Y label to be passengers with a capital P. And then there are also some helper functions. So instead of using labs and specifying those things inside labs, you could use plus X lab, and that would just change the X-axis label, or plus Y lab and just change the Y-axis label. Now, how do you change the tick, the format for the axis ticks over here? You want to use this package called scales. which has a bunch of different scales. Like it'll have scientific notation. It would have all sorts of things. And anytime you want to change something to do with x-axis or y-axis scaling, you use this function, or which you add to the call to ggplot. You're either going to use scale x continuous, which that's for if we want to make changes to the x scale, y continuous for changes to the y scale, or scale x discrete if the values are discrete and not continuous. In this case, we want to change the y-axis scale. It's continuous scale, right? It's just the number of passengers. So we would use this call here. And I'm just adding on, right? I'm saying, okay, now I'm going to add scale y continuous, and I'm going to tell it the labels equal comma, which is how you would specify tick axes, which are just the raw numbers with a comma in them. So you can see that once you basically understand that all ggplot calls have this basic ggplot function, they have a geom, and then you just add stuff on to make changes. It's very simple to make changes to these plots. Another thing you might be interested in are changes to the defaults for the plot appearance. So you can see that kind of all ggplot default plots have this kind of gray background. They have these grid lines there. Some people don't like that. So to change that, you would make, you would add something to this theme function, right? So just, you would take your basic ggplot2 call and you would add a theme function, and you could change things inside of that. I'm not going to go into all the things you could change in theme. What is probably worth knowing is that there are some default themes. So if you really quickly want to change a lot of stuff about the appearance of the plot, you just add these default themes. So for instance, I add this theme dark, and we get a darker plot. There's a package called GG Themes that contains a lot of user-created themes, and you can, many of them replicate popular publications. So I've shown two here. Theme WSJ, which is replicating what you would find in the Wall Street Journal, or Theme Economist, which replicates what you find in Economist magazine. So once you have your basic plot going, if you want to kind of jazz things up very easily, you can just add this theme argument and add a default theme. So everything so far has basically been a line plot. If you want a different type of plot, that is a different geom, right? So you just change the geom. So I'm going to just show you some variations on this plot. Maybe we want to do a scatter plot instead of a line plot. Here I'm making almost exactly the same call to ggplot, except I use the point geom. So that is the ggplot way of denoting a scatter plot. It's called the point geom. But you see that everything else is exactly the same. I've only changed the name of the geom. We might want a smoothed line going through all the points. that can be had with the smooth geom, and which I just add with another layer, right? So if you're kind of trying to think of this as this grammar of graphics that ggplot2 has, we have this first call that specifies the data space. We have the first layer, which is the geom point or the scatter plot layer. And then we're going to add a second layer, which is the geom smooth layer, right? Which creates these smooth lines. We might want to have a kernel density estimate, right? In ggplot2, that's geom density. And we get a nice kernel density estimate. This is one of the things that's a little different and nicer about ggplot2 compared to base R is that it actually has kind of, it has an intrinsic method of plotting density estimates. So you would, I'm going to say this probably a third time. You're I'm sure rolling your eyes, but once you understand that ggplot is, all ggplots basically look the same. They're just this initial call where you tell it what data to look into, and a geom, it's very easy. You can go online and get a list, complete list of all the geoms that are available in ggplot, and very simple to make any type of graph you want. Aesthetic mappings. So when we talk about aesthetics, we're talking about inside the geom, you have this mapping equal AES. I think AES stands for aesthetics, where you specify these different aesthetics. So I'm going to go back to our line plot, and one of the aesthetics we had in that was called color, and we were sending the year variable to color, right? So it knew everything that where the year variable is 2020, we want to be one color. Every observation where the year variable is 2019, we want to be another color. Well, we can play around with that aesthetic, and instead of using color, there are a number of different aesthetics that you can change. If you look at the help documentation for the line geom, you'll see these. I'm just going to show them briefly. So alpha, instead of mapping color to mapping the year to color, maybe we map it to alpha. Okay, this is what we get. You can see the alpha basically has to do with, I suppose, the grayscale or the shading of the line, right? Because 2019 is gray, 2020 is black solid line. We could map it to the group aesthetic. That just tells ggplot to group by year. Do nothing else. So don't make the color by year, don't make alpha by year, just group by year. So that's probably something we wouldn't want to do because you can't tell which year is which. We could use the line type aesthetic. You see that each year has a different type of line, a solid line versus a dotted line. We could send year to the size aesthetic, right? Where, okay, now we get 2019 is a moderately sized line and 2020 is a very fat line. So there are a lot of these aesthetics that you can play with. Different geoms have different aesthetics that are available. So you would need to go in the help documentation and look at what type of aesthetics are available for different types of geoms. Another thing that's nice are coordinate systems. R has a lot of coordinate systems. I'm not going to spend any time talking about them because, for instance, polar coordinates. I've never used polar coordinates in my life. So my guess is maybe you probably wouldn't use them either. One function that is kind of nice is this coord flip, which I've spelled wrong here, but in the function call, this is correct. So if you add this coord flip, it will flip the axes, which is kind of nice if you have really, like really long tick labels axis. The chart can behave a little bit better that way. Okay. The last thing I want to talk about are what I'll call non-variable aesthetics. So these are plot aesthetics that don't have a variable map to them necessarily. So when I did my incorrect line plot, way up here, let me go back to that. I was using what I'm going to call a non-variable aesthetic. And what I mean is, if you look at this color argument in the line geom, that appears outside of the AES function, right? So when I was doing the correct plot, that color argument was inside AES, and I was sending the year variable to that. Here, it's outside AES, and I'm specifically telling it, okay, I want the color of this line to be blue. So that's what I mean by non-variable aesthetics. They're things that change the appearance of the plot, but you don't send a variable to those. You specify a specific value like blue or red or something like that. So to illustrate this, I'm going to use this diamonds data set, which has which contains information on different diamonds, basically. So it has like information on the size of the diamond, the cut of the diamond, the clarity of the diamond, those sorts of things. And this is included in some, I think it's in a base package in R, I believe. So you can read it in, you don't have to actually use, read in a CSV file or something like this. I'm gonna read that diamonds data set into a data set called diamond. And I want to create a bar plot. So I'm gonna use the bar geom. I want the X values to be mapped to cut, and the fill, so the fill of the bar to be mapped to clarity. And of course, in the y-axis for a bar plot, as we already know, the y-axis for a bar plot basically is a measure of the count, or it could also be proportion that you have. And so you see that this is kind of nice because we can see for each type of cut of these different diamonds, we can see the number that were of a certain clarity, right? So it's an easy way to visualize that. You can get a lot of different appearances of this, this bar plot by changing the non-variable aesthetics of the geom. So here I've changed this position aesthetic to fill, right? And we get something very different. We get a proportion. So instead of a count, we're getting a proportion on the y-axis. You could change the position to dodge. So instead of fill to dodge, and now instead of stacking these, it puts them next to each other. But all of these graphs basically display the same information, right? it's just a different way of displaying the same information. And so most non-variable aesthetics, that's basically what they're doing. They're not changing fundamental aesthetics of the graph. So if you ask me, like a line plot like this, the fundamental aesthetics of this plot are what's on the x-axis and what's on the y-axis. And in this case, maybe the line type or the color, because we want to distinguish by year. So the essential aesthetics are those that you're mapping variables to. These other aesthetics outside of this aesthetics call are not as important, in my opinion, and most of the time they don't really change the fundamental nature of the plot. So the last thing I just figured I'd mention is that plots can be saved manually using this ggSave function. You can also, there are actually a number of different ways you can save plots. In RStudio, you can use ggSave. You could use your PDF rendering engine. And let me plot this here just to show you how you would do it in RStudio. Figure which one I want to do. Okay. That's because I messed with my call to the. So if you're in RStudio, most likely the plot is going to show up in this window over here. The easiest way to save things, I find, is use this export function. You can save as an image or save as a PDF. My experience is I typically save as PDF. I'm not sure it matters, but you click that, you can change some of these settings for the size of the PDF output, whether you want portrait or landscape. You can get a preview. So this should open it up right in my in Adobe Acrobat and see what things look like. And then you just send it to a certain directory and click save. So you can do that, or you can actually write the scripts to save it whenever you run the code. But either of those are options for you. So I ran a little bit over longer than I thought I would. There's my little thanks to USDA for providing the funding. So that's the basics of using ggplot. If that's a lot of information to go over quickly, certainly doing it in DataCamp is going to tell you more, or probably help more than listening to me would do. But if there's one thing I would try and get across here, it's that really make an attempt to just understand the grammar of ggplot2. And the basic grammar is that you have this call to ggplot where you specify the data, and then you have a geom, and you need to have this mapping where you map variables to aesthetics of the plot. If you understand that, then it's very easy to make any type of plot you want in ggplot. you know, looking at the help documentation. Are there any questions about any of this? You can run through the R Markdown document yourself and kind of see how things are working. But the rest of the other hour, I was hoping to reserve for kind of people to go off and try some of these things in data camp if you're not familiar with ggplot. That's no questions, I think. There's never any questions. And I can't see that.
Okay, well, thank you very much, Ford. This was
Yep.
terrific. And to everybody, I've made the first data camp. I think you can get to everything by poking around, but I made it one of the assignments so you can get to it easily from your assignment.
Yeah. Yep. And I'm looking in the chat here. Yep. So yes, the HTML. So the R Markdown document is available. So you should be able to knit that, and you can knit it to HTML if you want. You can knit it to anything. Well, not anything, but you can knit it to PDF if you want, or something like that. So it would, so I think I saw other people teaching from R Markdown. So yeah, you will have access to this in the training repository, this document. And you just, you know, go up here and hit knit, and hopefully it works. It worked last time I did it, and it will, the only things you will need to change are the directory here for reading in the TSA data. I think that's the only thing. Yeah, that should be it.
And the image at the bottom for the USDA.
Oh yeah, the USDA, that probably just won't knit.
You have to
because-
comment
Yeah,
it, erase it.
yeah, because that's just from locally. So, but you know, you don't need that anyway. So you could just delete this little bit. No, the Russia visualization is, I don't know if there's actually, you probably could find the data set behind that, but that Russia visualization was hand drawn, you know, like 100, probably over 100 years ago, or something like that. The data set that's on there is the TSA data set, which allows you to plot this. So you can see how many fewer air passengers there are under COVID-19 than the previous year. Well, if there's no other questions, I think we can go. If Aaron, do you have anything?
No, sir. This was terrific.
Okay, great. Well, everybody go off, enjoy data camp. You should, it's a great resource. I think I'm actually high up there on the leaderboard of data camp, just because, you know, it costs money to get this otherwise. And through this program, we all have access to this thing. So, you know, make use of it while you have it. I mean, even if you're like me, where you've already done a lot of this stuff, going through data camp, I find myself learning some new, you know, tricks that I wasn't aware of before. So anyway, have a good lunch and afternoon.
Terrific. Thanks, everybody.